Okay, class. Now you are in week 4 of using Edgenuity with this online learning through HCISD. The goal for week 4 is we are going to define quadratic functions. The first way we're going to define quadratic functions is number 1, to identify the domain and range of a quadratic function. For those of you who forgot what domain and range is, that's your x and your y. The best way to describe or display domain and range is using tables. The x is your domain, the y is your range. Again, you put in the input and then you get an output. Another name for y using functions is f of x. F parentheses x parentheses. Step 2 in defining quadratic functions is we are going to analyze the rate of change and compare it to the rate of change of other functions. This is an important step when the view of a graph is not given and just an equation or just a table is given. Another word for rate of change from one of our units we covered from the very beginning of the school year is slope. And number 3, how we are going to define quadratic functions is we are going to evaluate. We are going to evaluate quadratic functions for a specific input value. So when they give us the x, we will find the y. What's another word for y? F of x. The key words that will be discussed during this week 4 will be quadratic function. What is a quadratic function? It is a nonlinear function that can be written in the standard form y equals ax squared plus bx plus c. The second word we're going to cover is a parabola. What is a parabola? It is the u-shape of the graph of a quadratic function. Remember, in the linear equations, everything was a straight line. For this one, everything's going to be a u-shape. The u-shape can be facing up or down. The third word we will cover is the parent quadratic function. And that's just simply y equals x squared. The fourth term is the vertex. The vertex is the lowest or the highest point on the parabola. So the lowest point, also called the minimum or the highest point. That can also be called the maximum. And the fifth word in our unit that we will cover is axis of symmetry. What is the axis of symmetry? It is the line that passes through the vertex and divides the parabola into two symmetric parts. What does all that mean? It's the line that cuts the graph in half. We are going to identify the a, b, and c values for the quadratic function. If you remember from the beginning of our notes, what is the equation of a quadratic function? It's f of x equals ax squared plus bx plus c. So when it says identify the values of a, b, and c, a is the number or the coefficient in front of the x squared, which in this example is -2. B is the coefficient in front of x, which is in this example, it's a +3 if you see the plus sign in front of the 3. And c is the last term, which is called a constant when a number is without a variable. And as you can see, it's 4. But look at the minus sign. The minus sign, when it says -4, tells you that c is actually -4. A function is a relationship between a set of numbers and another set of corresponding numbers where each input value relates to one of the output values. The domain is the set of all input values, or other words known as your x, and the range is the set of all output values, other words known as f of x or y. Examples include linear functions and exponential functions. Let's take a look at a quadratic function now. The parabola shown is the graph of a quadratic function f of x equals x squared minus 5. First, let's identify our values of a, b, and c. The number in front of x squared is simply going to be 1. If you look at for b, there is no value of x. So in this example number 2, b will be 0. And the constant at the end of the quadratic equation is a minus 5, so c is going to be negative 5. Now let's identify the domain and range. The domain is the set of all x values. By looking at the quadratic shown, the x value will go for infinity in the positive right direction and infinity in the positive left direction. This is true for all quadratics. Whether the quadratic is opening up or opening down, the domain will always be all reals, forever positive and forever negative. Now let's take a look at the range. The range again is the set of all y values. So looking at the graph, the y values are vertical, going up and down. Since this graph is opening up, it will go forever or infinity in the positive direction. Let's identify the lowest point or the minimum of this parabola. If you could tell by the line I drew, the lowest possible point that this parabola will reach is negative 5. So the range will be every value greater than or equal to negative 5. Now let me show you how a fancy way to show your answer. Determine the graph that represents a function is going to be our next example. There are 3 graphs given. The first graph is a circle. The second graph is a parabola facing the left direction. And the third graph is a linear line. How are we going to determine which represents a function? Is the vertical line test. So a vertical line drawn straight up and down cannot hit the graph at 2 points at the same time, only using a vertical line. So just like drawn, it hits the graph at 2 points, so therefore it is not a function. If the question is asked given a table or a set of numbers, remember the x cannot repeat. Looking at the next graph, vertical line test, I draw my vertical line, and again, the graph hits at 2 separate points, so therefore x is repeating. This is not a function. For those of you smart ones out there, you could tell by the third one, the vertical line test. I draw a straight line through the graph at every single point, and the x's do not touch twice. So therefore, the third one is our answer. The equation of a quadratic, as we learned, is y equals ax squared plus bx plus c. It could also be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a cannot equal 0. Which of the following equations are quadratic? Look at the first example. The x does not have an x squared. That's not a quadratic. The next example, you see the x squared? Ding, 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 ding. The third example, you see the x squared? Ding, 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 ding. The fourth one, let's say for the last, and the fifth one, 8x to the fourth. To the fourth, that's not a quadratic. Now, the last one, m plus 3 times m plus 3. As you remember of multiplying polynomials, you can use the box method or the FOIL method. And right away, let me ask you, what is a letter times a letter? M times M, M squared. When you see that squared, that tells you that the fourth one is also a quadratic equation. As you already learned, the graph of a quadratic function is called a parabola. In the equation ax squared plus bx plus c, if a is greater than 0, that tells you that the parabola will open upwards. Also, if you look to the right, when a is greater than 0, you'll also know that you'll have a minimum value. Your vertex will be a minimum. In the equation ax squared plus bx plus c, if a is less than 0, then you know your parabola will open downwards without even using a graphing calculator. If you look to the right, when a is less than 0, you will have a maximum value. Your vertex will be a maximum. The most basic quadratic function in the family of quadratic functions is called the parent quadratic function, is y equals x squared. The graph is shown. The line that passes through the vertex that divides the parabola into two symmetric parts is called the axis of symmetry. The axis of symmetry of this parent function is the y-axis. Another name for the y-axis in graphical terms is x equals 0. So your axis of symmetry is x equals 0. It'll always be x equals something that creates a vertical line. The lowest or highest point on the parabola is the vertex. In this case, the vertex is a minimum because my parabola is opening upwards. The vertex is at the origin, 0, 0. Let's take a closer look at the parent function of a quadratic. F of x equals x squared, or y equals x squared. As shown, we have the table and the graph. Looking at the table, let's take a look on what's going on. Negative 3. Negative 3 squared, because quadratic means squared, is equal to negative 3 times negative 3 equals positive 9. That checks. The next domain value, or x value, negative 2 squared, is equal to negative 2 times negative 2. That is a positive 4. That checks. Let's take a look at one more term. Look at the positive value of 1. This is the input. 1 squared equals 1 times 1 is 1. That checks. So the table is true to the equation given. Remember again, the x is the domain, and the f of x, or the y, is the range. In this next example, let's just analyze a quadratic equation. We have the equation y equals 2x squared minus 4. The a value is 2. There is no b value, so we give that a 0, and the c value is negative 4. We have a table given, a graph given, and an equation given. In the table, x is domain, and y is your range. Let's check to see if this table holds true. In the equation, y equals 2x squared minus 4, my x value is in between the 2 and the squared sign. Let's take our first domain value, positive 2. So, f of 2 equals 2 times 2 squared minus 4. We replace the x value with x in our equation. So 2 squared is 4. 4 times 2 is 8. 8 minus 4 gives me positive 4. So f of 2 equals 4. That checks. Our next domain value, 0. F of 0 equals 2 times 0 squared minus 4. 0 squared is 0. 2 times 0 is 0. 0 minus 4 gives me negative 4. That checks. Let's take a look at one more domain value. Negative 2. F of negative 2 equals 2 times negative 2 squared minus 4. Negative 2 squared is negative 2 times negative 2, which gives me a positive 4. A negative times a negative is always a positive. Positive 4 times 2 is 8. 8 minus 4 gives me 4. So f of negative 2 is positive 4. The table checks. Again, as we learned, when a is positive number 2, our parabola opens up in the up direction. The graph checks. And our vertex is a minimum, the lowest point of the parabola. And let's take a look where that is. That is at the point 0, -4. And the axis of symmetry would be again the y-axis, or in equation form, x equals 0. Let's analyze the next example of our quadratic equation. We have the equation y equals -2x squared plus 4x plus 5. Let's identify the a, b, and c value. The a value is the number in front of x squared, or -2. The b value is the number in front of x, or the coefficient. And the c value is the constant with no letter or no variable at all, +5. The -2 tells us the graph opens downward. Now let's find the axis of symmetry. The equation of axis of symmetry is x equals -b divided by 2a. The b value in our example given is a +4. And the a value in the equation given is -2. So the minus b will now be a -4 in the numerator and in the 2 times -2. 2 times the -2 is a -4. -4 divided by -4 is a +1. Negative divided by a negative is a positive. So that tells us the equation of the axis of symmetry always is going to be x equals a number, is x equals 1. So we can find the axis of symmetry with just the given equation. Let's do a recap on domain and range. The domain is our x value, or +3, +2, +1, 0, -1. And the range is the y value. As you can see, our graph is opening downward. Remember, domain is always going to be all reals for quadratic. Infinity to the left, every negative number, and infinity to the right, every positive number. The range in this case is we have a maximum. The maximum point is a +7. So the range is going to be every number lower or equal to 7. So y equals less than or equal to 7. A projectile motion is modeled using a quadratic function. F of x equals ax squared plus bx plus c. Juan is studying medieval catapults that were used to protect castles. He recorded a reenactment and plotted the path of a projectile at different heights each second after the launch. So let's look at the table. We have an x and y value. Our x value, the domain, is seconds. The total time the object was in flight, from 0 to 5. The y value, or the range, is the height of the object off the ground at that specific second. Let's look at the plotted points. In our next projectile motion problem, the table represents the height in meters of a baseball a pitcher threw to another player after a certain number of seconds. What are the missing values in the table? Finding A and the B value. First, let's look at the x value in seconds. We know it goes from 0 to 6. So the vertex, the halfway point, is at a time of 3 seconds. And at 3 seconds, the ball is 41.1 meters off the ground. Now, from 41.1 to 39.2 for 2 seconds, that matches with 4 seconds. So for the match for 1 second at 24.5 meters of a height off the ground, at 5 seconds, our letter A would also be 24.5 meters off the ground. At a time of 0, the baseball was 0 meters off the ground, so that matches with 6. At 6 seconds, letter B will be 0 meters off the ground. Is this a realistic situation? I would say no, because how can a pitcher throw the baseball when the baseball is 0 meters off the ground? Let's review some vocabulary really quick before we go to our next goal. Slope. It's the ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points on a non-vertical line, represented by M. The rate of change compares a change in one quantity to a change in another quantity. So rate of change involves things happening in the real world. They are identified as the same thing. When finding the slope or rate of change when given a graph or a table, you have to choose any 2 points. The equation of finding rate of change is y2 minus y1 over x2 minus x1, the rise over the run. When finding the slope, the 2 points, it must be consistent. When the y is subtracting the y, it has to correspond with the x subtracting the x. So let's take a look at the parent function, f of x equals x squared. Let's find the slope between the given points. Of the point, positive 3, positive 9, and 2, 4, we look at the slope. The rise is 5, and the horizontal run is 1. So my slope is 5 over 1, or 5. Let's look and find the slope between the next 2 points, the point 2, 4 and the point 1, 1. The rise between those points is 3, and the horizontal run is 1. So the slope is 3 over 1, or 3. When looking at the rate of change of quadratics, it will never be constant. In this example, we are comparing the rate of change between a linear line and a quadratic line. The linear line f of x equals 1/2 x minus 2 is shown below. The slope between the points is 1/2. The rate of change is constant. If you look at the quadratic equation, g of x equals 1 half x squared plus x minus 2. The rate of change is not constant or changing amongst the points. Side note, when it says g of x equals 1 half x squared plus x minus 2, it's the same thing as f of x. They're just changing the letter, so don't be intimidated. The rate of change is rise over run. Different rates of change, not constant. Now let's begin evaluating functions. In a given example, we have f of negative 4, f of 0, and f of 1. That's the same thing as looking at a table when the x value is negative 4, when the x value is 0, and when the x value is 1. So the first value, x negative 4. On the graph, you go to the left or horizontally to negative 4, and then you go up how many spaces? 6. Be careful that the y-axis is labeled in 2s. 2, 4, 6, 8, and the x-axis is labeled in increments of 1. Now, the next one, f is 0. When x is 0, so you do not go to the right or left, you stay in the origin. And how many spaces would you have to go down? 6 spaces. In the downward direction, that's negative 6. So f of 0 equals negative 6. And the last one, f of positive 1 equals, you go to the right 1 starting at the origin, and you have to go down how many? Negative 4. 4 spaces in the downward direction. So f of 1 equals negative 4. Now let's evaluate this function for an input of negative 3. Remember, input is my x. So f of negative 3 equals what? So starting at the origin, 0, 0. Negative 3x, I go to the left or right. Go to the left 3 spaces, and then I go up how many until I hit my point? Positive 4. So the evaluation of the function for the input of negative 3 would be the output positive 4. Let's look at another instance with this same example. What about f of positive 2? Try to find it on your own. Start at the origin, 0, 0. When x is 2, positive 2, you have to go in the right direction, 2 spaces, and then find where it hits your graph, or intersects your graph, at the point positive 9. So the correct way to write our answer is f parentheses 2, close your parentheses, equals 9. Or in the table value, x is 2, y is 9. Now let's evaluate this quadratic function. G of x equals negative 2x squared plus 3x minus 5. We're going to evaluate for the input values at negative 2, 0, and 3. So in a sense, we're going to have to do 3 separate problems. F of negative 2, f of 0, and f of 3. These 3 numbers are going to be replaced in our x value in the equation negative 2x squared plus 3x minus 5. How many different locations do you see the variable x? I see it in 2 different places. Ax squared plus bx, or negative 2x squared plus 3x. Okay, class. Notice how I'm writing out the equation, the same equation, 3 separate times, because we are evaluated at 3 different input values. So, negative 2 blank squared plus 3 times blank minus 5. Remember, parentheses mean multiplication. So let's evaluate the first one, negative 2. I'm going to fill in negative 2 where I left a blank, or my variable x. Negative 2 squared. That is, negative 2 times negative 2 is a positive 4. Positive 4 times a negative 2 is a negative 8. 3 times negative 2 is negative 6, and then the minus 5 follows. Negative 8 plus negative 6 minus 5 will give me a value of negative 19. So I answered my first input value. F of negative 2 is equal to negative 19. If I would write out a table, an xy table, one of the coordinate points would be negative 2, negative 19. Now the next one, f of 0. We always gotta love zeros, because anything times 0 is always 0. So f of 0 is equal to negative 5. We're almost there. If we were making a table, the x value would be 0, and the y value would be negative 5. Also our y-intercept. And the last one, f of 3. 3 squared times negative 2 plus 3 times 3 minus 5. Negative 18 plus 9 minus 5 will give me a total of negative 14. So we have found the output values for all the input values. Or another way to say it, we have found the y's when we were given 3 different x values. It all means the same thing in different vocabulary. Let's do one more the exact way that we just did one, except this time our function is negative x squared plus 2.4x plus 5.8. We're going to evaluate for 3 different input values, or 3 different x values, negative 2, 0, and 3. So the same steps as last time. I'm going to write it out 3 separate times because we have 3 different input values. If you were to graph this, you can graph, Control T, find a table, and it'd be a lot easier, but we are doing it by hand. How many different places do you see x? I see it in 2 different places, in between the negative and the squared sign, so negative x squared, and then multiplied by the 2.4, 2.4x. So I'm going to write out the equation 3 different times, leaving a space blank where I see the letter x. Remember, we are evaluating functions. If you get confused or have questions at any point during this video or lecture, Feel free to email your teachers. So the first value is -2. Let's plug in -2 in our blank spot. So I have a negative times a -2 squared plus 2.4 times -2 plus 5.8. Enter that in your calculator exactly how you see it. The next one, f of 0, I have -0 squared plus 2.4 times 0 plus 5.8. I'm just emphasizing of the f of whatever's inside the parentheses just replaces the x. And then last one, f of 3 is -3 squared plus 2.4 times 3 plus 5.8. Be careful when you're squaring a negative. That's a big mistake a lot of students make. A -2 squared, negative times a negative is a +4. But there's a negative sign on the outside of that parentheses. So -4 plus -4.8 plus 5.8 is a -3. f of -2 equals -3. -0 squared plus 2.4 times 0 plus 5.8 is going to give me a final total of 5.8. So f of 0 is just equal to 5.8. And the last one, negative parentheses 3 squared plus 2.4 times 3 plus 5.8. -9 plus 2.4 times 3 is 7.2. 7.2 plus 5.8. You put that together and you get a f of 3 is equal to +4. Again, when you have f of a number is equal to a number, it is the same thing as making a table. So I'm going to display it one more time so you can see what I mean. So we have f of -2 equals -3, f of 0 equals 5.8, and f of 3 equals 4. What does this all mean? Make a table. With a table, then we can now graph the points, but I will not graph this example. I just want to emphasize the table part. What's another name for y? F of x. Let's finish off this week 4 lecture with one more example just to make sure we understand. Evaluate the function for an input of +1. We just have a table. Input means x, or my domain. I find +1. What does it correlate with? -3.8. So again, input of 1 when the x value is 1, when the domain is 1, f of 1 equals -3.8. So, in summary, what did we go over in this week 4 video? We wanted to define quadratic functions, the equation y equals ax squared plus bx plus c. How did we do that? We identified, we analyzed, and we evaluated. We identified the domain and range. We analyzed the rate of change between different graphs, including quadratic, linear, and exponential, and we evaluated. F of a number is equal to a number, or whatever x value is, we're finding the y value, and input, finding the output. Thank you very much. Have a wonderful week.